All right, gentlemen, if you are watching this video, then it is very likely that we have a snow day or that we don't have a snow day, but your parents took a look outside and said, you're not going to school in this mess. So we are going to do today's math lesson together. Just as a reminder, you should take the notes that I have. There'll be some independent practice that I'll expect you to do on your own. You can turn this in tomorrow. Or sorry, tomorrow would be Thursday. This is Tuesday. So you can turn this in on Thursday, the 8th. And again, if we do not have a snow day, if we are in school tomorrow, you can click stop on this video because you don't need it right now. We're going to do it in class. Okay, great. So let's first activate prior knowledge. Mr. DeShriever is trying to decide which type of sandwich to make for dinner. He has 3 types of bread. He has white, wheat, and sourdough, and 2 types of cheese. He's got cheddar and American. Mr. DeShriever, I actually don't know if that's how you say his name, but we're going to go with that. Mr. DeShriever wants a sandwich with 1 type of bread and 1 type of cheese. Represent the sample space of this situation using an outcome chart. And an outcome chart is what we worked on today. And so in this case, I have 2 events, okay? Event 1 is bread. Event 2 is cheese. Okay, and so I'm going to go ahead and build my outcome chart. So I will do my bread. So that's white, wheat, and sourdough. Okay, and my cheese choices are going to be cheddar and American. Okay, so I could go, we're going to say white is WH and wheat is WT. Okay. So I could have white bread with cheddar, white bread with American, wheat bread with cheddar, wheat bread with American, or sourdough bread with cheddar, sourdough bread with American. So I have this sample space, and what that tells me is that these are my 6 possible options for a sandwich if I want to use 1 type of bread and 1 type of cheese. Make sure you have that in your notes. And so how many possible sandwiches can we make? The answer is 6. And that brings us to something that Caden and a lot of folks in LIU came up with yesterday on their own after seeing this pattern, which is the product rule. Okay, so go ahead and get your pencils ready. We're going to talk about the product rule. The product rule tells us that to find the total possible outcomes for a compound probability probability. Find the total possible outcomes for probability experiment, comma. We can find the product of the numbers of outcomes for each event. So to talk about that with our sandwich model here, for the bread, we had three possible outcomes. We had wheat, white, or sourdough. And for the cheese, we had two possible outcomes. We had cheddar or American. If I multiply those together, I get six possible outcomes, and that is the total number of outcomes that I will have. Okay. So this was kind of a review of what we did yesterday, So let's move on. And we're going to talk about a tree diagram. And I know that I did do a tree diagram because it is really important and it's something that's great for when you have more than two events. But we're going to really try to master that today so that when we move into more complicated compound probability, it's not going to feel too tough at all. All right, so I'll go with green. Mr. D is trying to decide which type of sandwich to make for dinner. He has three types of bread, white, multigrain, and sourdough. This is going to sound familiar. White, multigrain, and sourdough. And two types of cheese, cheddar and American. Mr. D wants a sandwich with one type of bread and one type of cheese. Represent the sample space of this experiment using a tree diagram. So essentially what I'm going to do is the exact same thing. Okay, so my event one, I'm going to put E1 up here. My event one is bread. My event two is cheese. Okay. Event B, event C. Okay. So I'm going to have my white, my wheat, and my sourdough. And then for each of these, I could choose either cheddar or American. Cheddar or American. Cheddar or American. Okay. And then I can use this space over here to list out my possible outcomes. And so this would be white, cheddar, white, American, wheat, cheddar, wheat, American, or sourdough, cheddar, sourdough, American. Okay. So I just did the same problem in two different ways, and I was able to list the outcomes. When you're working with a tree diagram, it's these last set of branches that let you know the number of outcomes. Okay, so the number of outcomes is 1, 2, 3, 4, 5, 6. So it's when you get to that last branch that you have the number of possible outcomes. But let's turn this up a little bit. Let's make a more interesting sandwich for Mr. D here. So he decides that he wants to either put mayonnaise or mustard on his sandwich. Create a tree diagram, another tree diagram to show all the possible combinations. Okay, so here I have three events. My event one is bread. My event two is cheese. And my event three is the condiment. Okay, so same deal. And these can get really sloppy really quickly, so it's important that you try to be as neat as possible. So I'm going to have my white bread here, my wheat bread, and my sourdough bread. And I could either have cheddar or American, cheddar or American, cheddar or American. And now I'm going to have even more to choose from. I can have either mayo or mustard. So MA for mayo or MU for mustard. MA, MU. MA. Okay, so before I list my possible outcomes, I want to talk about how many possible outcomes there are and test that with our new rule. All right, so I'm going to highlight this. This is going to show me how many possible outcomes there are. Okay, and that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And for event 1, I had 3 possible outcomes. For event 2, I had 2 possible outcomes. For event 3, I had 2 possible outcomes. So with my rule, this should equal 12. 3 times 2 is 6, and 6 times 2 is 12. Great. So we're in a good place. So I'm going to write out my outcomes. White, cheddar, mayo, white, cheddar, mustard, white, American, mayo, white, American, mustard, wheat, cheddar, mayo, wheat, cheddar, mustard, wheat, American, mayo. Oh, I didn't mean to write that out. Wheat, American, mustard, sourdough, cheddar, mayo, sourdough, cheddar, mustard, sourdough, American, mayo, sourdough, American, mustard. Cool, so I've got my tree diagram. I've got my outcomes. I've tested to make sure that this follows along with the product rule, and it does. And now we can move on. Make sure you have these notes. All right, we have more guided practice, which is always super helpful. Let's take a look. Elena creates a tree diagram to show the tree diagram to show below. Shown below. There's a little typo here. The tree diagram shown little n below to represent all the outcomes of flipping a coin 3 times. So this is event 1, this is event 2, and this is event 3. In the table, list the compound outcome, list each compound outcome from the tree diagram. So what does that mean? That means I'm going to go, okay, so my first possible outcome is heads, 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 tails. All right, and let me show you how I'm following this. So I'm going heads, 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 and then I'm going heads, heads, tails. Okay. And I'm still on heads here, so I'll do like pink. And then I'm going to go heads, tails, heads, and that kind of covered the head so you can't see it. So let me write that down. Heads, tails, heads. I'll go with a little blue. All right, heads, tails, tail. So down here, I'm going to go tail, head, head. tail, head, tail, 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 head, and tail, tail, tail. All right, so these are my possible outcomes. So I did that, number one, listing each possible outcome. Oops, sorry guys. How many total possible outcomes are there from flipping the coin 3 times, and what part of the tree diagram can we use? Okay, so the total number of outcomes, excuse me, I know by looking here is 1, 2, 3, 4, 5, 6, 7, 8. There are 8 total outcomes. Let's see if that fits our product rule. So if I have a choice between heads or tails, times the choice between heads or tails, times the choice between heads or tails, I'm going to get 8, okay? So I get 8 possible outcomes, and I can use the product rule, or I can use the last branches of the tree diagram. So I have 8 possible outcomes. And I want to use the last branches of the tree diagram. All right, take a moment now. If you need to rewind a little bit, make sure that you have all of my notes. If you have any questions that you're going to want to ask me when you get back, it's a good time to sort of jot them down. And I want you to try the independent practice mild on your own. Pause the video, take a few minutes to get it done, and then if you wanted to hit play, I will go over it. Okay, we are going to go over the independent practice mild. Charlotte is playing a board game using dice. She represents her possible outcomes below. Label the events and outcomes of the compound probability. Okay, so this is event 1, and this is event 2. Okay, and to be totally honest, not really sure why it had to start at a point up here. It doesn't, in fact, but those are your 2 events. So how many dice did Charlotte roll? We can see here, this was event 1, this was event 2, she rolled 2. How many outcomes are there? Well, in event 1, there were 6 possible outcomes. In event 2, there were 6 possible outcomes. So I'm thinking we should get 36. Let me just count to double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Great. So product rule, and then I can even double check. I have 36 possible outcomes. Star the outcome that shows Charlotte rolling 2 1s in a row. Okay, so if I go up here, I know that where she rolls 2 1s in a row, it has to be part of this branch. Okay, and I'm going to go down here, and this would be her rolling a 1 and a 1. So I'm going to put a star right there. Okay, she's rolling a 1 and a 1. Moving right along. Which tree diagram represents the sample space for the experiment of flipping a coin and spinning a spinner divided into 3 sections labeled 1 through 3? Select all that apply. Okie dokie. So I'm looking for flipping a coin, spinning 3 sections, 1, 2, and 3. So right here, this does not work for me, right? Because I don't have anything here. I have sort of event 1, event 2, but they're not overlapping each other at all. They're not connected, and they need to be. Okay, so that's not there. I'm looking at number 2. I have heads and tails. This is pretty good event 1. This is my flipping a coin. And my event 2 is my spinner. And I should have, because it's 2 outcomes in the first event and 3 possible outcomes in the second, I should have 6 total. 1, 2, 3, 4, 5, 6. And I do, okay? And I'm going to just check heads 1, heads 2, heads 3, tails 1, tails 2, tails 3, and I do. So this is definitely one correct answer. Let's move over to C. And we got a little confused here. Our charts are not going to look like this. Let's take a look at D. And it looks like in D, maybe we just switched the events, okay, which is okay, right? So I have my spinner here and my coin here, and my spinner has 3, and each of the possible outcomes is here. I could put 1 heads, 1 tails, 2 heads, 2 tails, 3 heads, 3 tails. So I have 6 possible outcomes. D would also be an accurate representation, excuse me, of the possible outcomes. Let's take a look at number 6. A student is performing a probability experiment. Okay. She spins the spinner shown below. And so she spins the spinner shown below. That's going to be my event 1. And she flips a coin. That's going to be my event 2. So I want to represent the sample space using a tree diagram. Okay. So in this case, I'm going to do one of these sort of downward facing tree diagrams, and I'm going to go, I'm actually going to start with the coin. Actually, no, I'll start with the thing. So event 1, I'm going to have red, yellow, blue, or green. And since I'm flipping a coin, each of these can either have heads or tails, heads or tails, heads or tails, heads or tails. And I have 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes, which makes sense because I have 4 outcomes on the spinner and I have 2 on the coin. So I have 8 total. All right, so this is my tree diagram here. Take a moment and get that down if you didn't have it already. I'll label event 2. Number 7. A student flips a coin twice. So those are my 2 events. Represent the sample space for this probability experiment. Okie dokie. So in this case, it doesn't indicate whether or not I can do a tree diagram or, the graph that we learned about on Tuesday's lesson. I'll do a tree diagram here. So I have my heads, my event 1 is the first coin, and tails. And my event 2 is the second flip, okay? Still heads, tails, heads, tails. And then I do, because I want a sample space, I do need to go ahead and copy here. So I have head, 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 tails, tails, head, tails, tails. So that's one way to do the sample space there. Moving right along. We have our independent practice medium, and I want you to go ahead and try to do that on your own. And then you can come back to the video and we'll go over some of it together. All right, let's go back to our game of rock, paper, scissors. So James and Reese are playing rock, paper, scissors again. And remember, paper beats rock beats scissors, and scissors beats paper. A tree diagram of the possible outcomes is shown. Answer the questions that follow. How many outcomes are possible? How many outcomes are possible? And I know that with rock, paper, scissors, each person has 3 possible choices. And so the number of outcomes possible should be 3 times 3, and that would be 9. All right, so it's C9. Let me erase that and circle it my C. What does the outcome, which is starred, represent? Explain in words. Okay, so in this outcome, I have James, and it looks like he shot paper, and also Reese. So in this outcome, both James and Reese chose paper. Okay. In how many outcomes will James win? Circle these on the tree diagram and list them below. Okay, so let's see here. I'm going to use a green highlighter for when James wins. So when James goes paper and Reese says paper, that's a tie. He doesn't win. When James says paper and Reese says rock, we know that paper beats rock. So here's one situation. And when James says paper and Reese says scissors, Reese would win. Moving down here for James. If James says rock and Reese says paper, we know that Reese wins. If James says rock and Reese says rock, we have another tie. If James says rock and Reese says scissors, we have another case where James will win. If James says scissors and Reese says paper, we know that James will beat Reese. If James says scissors and Reese says rock, we know that rock will beat scissors. And then if James says scissors and Reese says scissors, we know that we have another tie. Okay, so the possible outcomes for James to win would be if he chooses, so I'll say here, this is James and this is Reese. So the possible outcomes for James to win are going to be paper, rock, rock, scissors, and scissors, paper. All right, and so that's 3 out of 9, and it kind of makes sense, right? You have 3 possible outcomes. You have a tie, you win, or you lose. So it would make sense that in 9, with my 9 possible outcomes, 3 of those are winning outcomes for James. And of course, there are 3 that are winning outcomes for Reese as well. Okay. Mrs. Griffith is going on a shopping spree. Sounds like fun. She purchases the following items. She'll pick 1 piece of jewelry and either wear pants or a skirt. Represent the sample space showing all possible outfit combinations. I actually don't know why this is. Okay. Sorry, got rid of that. Okay. So I will do here, I'll do a tree diagram. Why not? Okay, so my event 1 is jewelry, and my event 2 is the bottom that she picked. So I have earring, necklace, ring, bracelet. Okay, and for event 2, I have skirt or pants. Okay, so I'm going to go S or P, S or P, S or P, S or P. I'll make this over here. Okay, so this is my event 2. And then I'll list out my events. Okay, we could do earrings and a skirt, earrings and pants, a necklace and a skirt, a necklace and pants, a ring and a skirt, a ring and pants, or a bracelet and a skirt, or a bracelet and pants. Okay, so that should be 1, 2, 3, 4, 5, 6, 7, 8 outcomes. Moving on. Mr. Dupree and Mr. Smith are performing a game where each person rolls a 6-sided die. So I have these two people and they're playing this game. If the sum of the numbers is greater than 9, Mr. Smith wins. Okay. Represent the sample space for this game using a tree diagram. Okay, so this is kind of what I'm envisioning. I'm envisioning that both of these men have one 6-sided die and they both throw it at the same time. And Mr. Smith wins if it's greater than 9. All right, so let's go ahead and do the tree diagram. Okay, so we'll say this is Mr. Smith. We'll make him event 1. All right, and he's either going to get, oh, sorry, it's not a coin. Get a little neater. So this is Smith, okay, and he's either going to do 1, 2, 3, 4, 5, or 6. And this gentleman is when we have to be super duper neat. Okay, so I know that 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Zip, zip. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And finally, 1, 2, 3, 4, 5, 6. Okay, so I have my sample space here, okay, and I'm going to actually list all of the possible outcomes. I know that that's maybe a little bit annoying, but I think we can handle it. So it could be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. Okay. Whew. Star the outcomes where Mr. Smith wins. All right, cool. So I'll use a highlighter. So I'm looking for where we get an answer that is greater than 9. Greater than, meaning 9 is not going to be a part of that. Okay, so I'm going to go through. 6 plus 6 is 12. 6 plus 5 is 11. 6 plus 4 is 10. And then these don't give me greater than 9. 5 plus 6, 11. 10. This is not greater than 9. 4 plus 6 is 10. And then I know now that I'm not going to have anything else greater than 9. So 3 plus 6 is 9. 3 plus 5 is 8. 3 plus 4 is 7, and so forth and so on. All right, so there are only 1, 2, 3, 4, 5, 6 ways that Mr. Smith can win by getting a 10 or more or greater than 9. Okay, so this means that this game is not fair. Okay, this game is not fair because Mr. Smith only has a 1, 2, 3, 4, 5, a 6 in 36 or 1 in 6 chance of winning. So it's not a fair game. All right, guys, this video feels like it's been going on forever. We will take a look at one of the independent practice spicy. I want to go through and just say you do not have to do mathletes. If you do choose to do mathletes, I'll give you a couple extra credit points. I would love for you to do the exit ticket, please. And the homework. Okay, so do the exit ticket and the homework. And don't worry about mathletes. We'll do spicy together. All right. Mr. Robinson is making a sandwich. In addition to several choices of cheese, he has 2 choices for a meat, ham and turkey, 3 choices for a bread, white, wheat, or multigrain, and 2 choices for a spread, mustard or mayo. If he can make a total of 24 sandwiches that include mayo, how many choices of cheese does he have? Okay, so Mr. Robinson, he's making a sandwich. All right, I want to do a key information box here. All right, so I have the meat event. There are 2 choices. I have the bread event. There are 3 choices. And I have the condiment event. There are 2 choices. And I have the cheese event. And I don't know how many choices I have there. And so what I want to know, if there are 24 sandwiches that include mayo, then how many choices of cheese are there?